This session illustrates how to create a complex well and shows the influence of near-well upscaling on the model response. The complex well is available for any numerical analysis in Saphir, Topaze, and Rubis. We create a new Saphir file, set the pay zone to 150 feet, and retain all other parameters at their default values. We start under the Map tab. Since a Saphir analysis always has at least one well, we can skip the step to add a well and jump straight to defining the complex geometry by double-clicking on the well and either drawing interactively or loading a trajectory. Let us start interactively. We set the well type to complex, switch to top view, enable well edit, and interactively increase the lateral well projection by simply holding and dragging the node. In both modes, top view and cross-section, additional nodes may be added by double-clicking on the well while in the edit mode, which can then be moved around. We then switch to the cross-section display, enable well edit, and interactively create and move the nodes. For this illustration, we have a well trajectory in XY TVD subsea format that we load as shown. By default, the entire well length is perforated. To edit the perforation length or add additional perforations, we enable Perforation Edit and interactively resize the existing perforation by simply holding and dragging the perforation node. A new perforation can be added by clicking on the new perforation icon and clicking anywhere along the well trajectory as shown. Perforation start and end measured depths can also be defined in the parameters grid. A skin can be assigned to each perforation, but we will keep it as 0 for this illustration and validate the geometry definition. A preview of the grid is visualized by clicking on the grid icon. The grid is automatically generated using default parameters. We keep the defaults for now. Now let us generate some test design data to see the model response. In the Additional Tools tab, we access the Numerical Test Design option. To generate a pressure response, we first enter a production history, as shown, and set the reservoir vertical anisotropy to 0.1. A set of pressure data are generated and the 3D plot is displayed. We extract the pressure data and generate a numerical model with the same parameters. Let us now maximize the 3D plot. To see the complex grid around the well, we increase the vertical gain and reduce the grid opacity. By selecting the 2D XY view, horizontal cross-sections at different depths can now be viewed. While in the 2D XY view, we draw a polyline through the well to create a vertical cross-section. Once done, we can switch to the 2D XZ view and select the polyline just created to view the cross-section of the complex well and the corresponding grid. We can play back the pressure fields that were saved when the model was generated. Let us now investigate the influence of well upscaling on the model response. We create a duplicate of the existing analysis and access the Grid Preview dialog. Uncheck Optimal Well Upscaling and set the upscaling to Coarse. When the updated grid is generated, we can see the reduced number of grid cells compared to the default Saphir upscaling. Getting back to the Analysis tab, a numerical model with the same reservoir properties is generated. This model shows a different behavior at early time on the log-lot plot due to the upscaled grid around the well. This concludes this Saphir session on the complex well geometry.